What's going on, guys? Let's look at this problem right here. Here this question is asking, for the circuit shown in figure 5.14, determine the collector bias current. Assume beta is equal to 100 and Is is equal to 10 to the power minus 17 ampere. Verify Q1 operates in the forward active region. Okay, now here we are asked to find out the collector bias current, and also we are going to verify this Q1 operates in the active region. Okay, now to prove this, first of all, like considering the current, we have to realize that voltage required for this one is relatively high. Usually this kind of problems we assume VB is equal to 800 millivoltage, this as an initial guess, and then we solve this problem. IB is equal to VCC minus VBE divided by RB. VCC is already here, 2.5 voltage minus 800 millivoltage, 2.5 voltage divided by RB, that is 100 kilo ohm, and that gives us 17 microampere. And from this one we can calculate IC, because IB is equal to IC divided by beta, that is 17 microampere divided by 100. IB is equal to beta times IC, so IC will become 1.7 milliampere. Okay, so 1.7 milliampere. Now we have IC. Now we can use this equation. VBE is equal to VT ln of IC over IS to get the accurate value of VBE, because we initially assumed 800 millivoltage. Now to get the accurate value we can use this equation. VT is always 26 millivoltage, ln of IC value we found out 1.7 milliampere divided by IS, that is 10 to the power minus 17 ampere, and if we solve for VBE, that gives us 852 millivoltage. Now we can go ahead and find out IB. Again we are going to use the same formula, but the values are going to be a little bit different. IB is going to be equal to VCC minus VBE divided by RB. In this case we are going to use VCC, same thing, that's 2.5 voltage, but VBE we are going to use the new one, the newly derived, that's 852 millivoltage divided by RB is the same thing, that's 100k ohm, and that gives us 16 microampere. Therefore IC is going to be beta times IB, that is 1.65 milliampere. Okay, now we have found out the IC. Now here the question is asking for the collector bias current, that is IC. Now this one is more accurate enough, because this is the one we found out again, and then it's closer to the previous one. Previous one is 1.7 milliampere, but this one also close to this one, so this is the accurate answer. Okay, now we have to prove whether this is in active region or saturation region. Now to prove that, we have to take the VC value. VC is equal to VCC minus RC times IC. That gives us 0.85 voltage. Now this value is nearly equal to VBE, because VBE value is 852 millivoltage. This one is 850 millivoltage. If you write in terms of millivoltage, this is 850 millivoltage. So this is a near edge of active and saturation modes. So it's at the edge of the both region. Okay, that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching, and if you're trying to learn electronics too, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.